region in Portugal, that is the Douro region where we produce the famous port of wine. I hope that you enjoyed this day. The weather in the morning is not helping and is not promising a good day, but we are climbing for the sun, for the afternoon, for you see and to see in the real condition our robots working in the real conditions. This event is co-organized by 4 entities that in Hashtag that I belong to, and it's also pushed by IoT, where Luís Alcino will make some few words about this Center of Competences in Portugal. It's also co-organized with SOGRAF and with support that we thank a lot for their support on this organization. So, I will pass to Luís Alcino to say some few words about IoT, explain what it is, and then we will start our event. So, welcome to all of you.
Good morning, everyone. On behalf of IoT, let me welcome you and welcome you to this open day dedicated to robotics. I will say just a little few words. I'm coordinating the IoT Competence Center. It's one of the 23 centers in Portugal, in this case dedicated to digitization and precision farming. It belongs to the Portuguese Rural Network. Robotics in agriculture has evolved significantly in recent years, offering innovative solutions that are particularly crucial for the cultivation of special crops like vineyards. In this particular region, as you see, Douro is notably represented by these vineyards and challenging slopes, demanding for all the time hard labor in terms of workforce, and so it's important to find solutions in this region that maintains the productivity of its primary economic activity, like this vineyard. As we all know, in this session, robotics is increasingly getting higher as an innovation technology that can be profitable in questions of quite a lot of tasks, becoming more secure to the operators and more productivity to the economy. So for us, in IoT, we share quite a lot this day. So because for us, for several reasons, it's important to be here. It's important, and we would like to thank to Inestec, ADVI, and our partners also, SOGRAF, for this event. For questions as IoT Competence Center for knowledge dissemination, which is one of our primary mission. Awareness and compassion, hands-on experience, networking and collaboration, and also to promote sustainable practices. In practice, agricultural robotics often to go hand in hand with sustainable farming practices, and all with this subject as well, profitably practice for farmers. So, welcome to this event, and thank you for the opportunity to be here. Special thank you also to the Portuguese Rural Network, Portuguese Actis, that is with us, in part for sharing this event, and also in part for supporting this event. Thank you all.
Okay, hello everyone. My name is Senka. I came from Serbia, company Dunanet. We are a software company, however, I'm the agriculture engineer, the only one here probably. In company there are 2 of us. And I actually usually speak to the farmers, trying to explain them how they can use new technologies, how they can digitize their practice, their knowledge, and how they can improve their activities and achieve better results. So it's a bit challenging when I'm talking to all of you that are, I think all of you are technical guys, so sorry if I made some mistake. We were involved in the Vineyards project that lasts actually for 4 years. Initially, the plan was 3.5 years, but then COVID happened and we extend a little bit the all activities. So the project partners from 18 countries, European countries. And I'm not sure what is going on, but okay, never mind. We organize our activities through 5 clusters. In each cluster, we had 4 different use cases, and under each use case, we have some pilot sites or few pilot sites, depending on how everyone organizes their activities. And the goal of the project is actually, or was actually, to boost digitization of agriculture, to help farmers to increase their productivity, to decrease their costs, to optimize their inputs, to achieve better results, to produce better quality of crops. And when we are talking about activities, the activities were organized through 5 clusters. One focused on arable crops, then precision farming, fruits and vegetables, livestock, and supply chain. So Vineyards was focused on the whole supply chain, from that primary production through transport, through every part of the supply chain to the consumers. And what we actually did is that we made different type of solutions easier. I don't know what is going on. Probably there is something that I didn't expect that will be here, like some presentation mode with something. So never mind, I will change the slides quite often. So we made easier data sharing between different providers, different platforms, devices, and with that we provide data to the farmers and allow farmers to have control on their data and not only use those data, but even to be able to monetize those data in the future, actually, probably not now, but in the future, to be able to sell data to maybe local government, to municipality, to some researchers that are willing to analyze data and to create some maybe ML algorithms that will solve some problems and things like that. And what else we did? We as a Vineyards consortium, we create a simple way for farmers and advisors to have all those results, services, components, and all enablers, and to can easily access them, and then to use them as new applications that will suit their needs. And okay, sorry. When we are talking about technical components, there is the agriculture information model that was created as a common language that allows different services to speak to each other. That means that different services could be used together at one application, and the farmers can benefit with using all those components together without switching from one application to another. And with this solution, they will have all data together and possibility to do some data analysis without, again, having to do that manually. They can automatically analyze all those data that we'll gather together. Then, from technical components, another one, the digital enabler hub was created. It's like a set of resources that are provided by different providers, so different companies that provide solutions to the farmers on the other side, And then we have consumers, like advisors and farmers, that can pick the suitable component or enabler that fit their needs and their requirements. And then another thing, stakeholder open collaboration space was created, like an online platform that is dedicated to all stakeholders as one place that, where they can find a bunch of information and where they can collaborate, discuss, and share their thoughts, and farmers can share their needs, providers can be aware of which type of solutions to have to be created. And I use actually the template from the matter, and that is why this is happening. Someone did something. And so after all, the whole event was dedicated to the farmers. And farmers have a number of benefits. And those benefits are from crop production, like saving in fertilization, saving in water usage, in energy usage, saving in pesticide usage, then some improvement in animal welfare, in milk protein content, and so on. So a number of benefits are there for farmers. And that is because of number of digitized solutions that they were used. And through all those pilots that I mentioned, so 20 of them, use cases, however, or whatever you would like to call them, farmers tested those solutions, and during all those 4 years, solutions were upgraded, and the feedback from the farmers was used for improving the solutions. And DunoNet company was involved in 3 use cases, and I will explain briefly all of them. So one use case was focused on poultry production. We collaborate with partners from Montenegro and Slovenia for this use case, and we installed different type of devices in poultry barns for monitoring environmental conditions in poultry barns, because that is very important for poultry production. And then we installed cameras to monitor chicken behavior and to try to estimate chicken weight. And during all these years, we actually created a machine learning algorithm that can estimate, that first can recognize chickens, then estimate the chicken weight, and then can analyze chicken behavior. And this is everything is very needed by the farmers. I mean, they need all those information to be able to better manage their production. And so there were benefits like improving of field conversion ratio, like improving of animal well-being, like less labor or optimized labor usage. And related to this use case, there was another one which was focused on supply chain transparency, and together with the Origin Jail company, and that was one of the part of Slovenia, we integrated their blockchain technology and providing transparency through the whole supply chain. And this energy labels that you can see here is something that we tried to create. It's like a first step. Not sure that this will going to looks like that, but something like we have on refrigerators or wherever, like energy labels to provide information if the production process is eco-friendly, let's say like that. Similar we did in Vineyards and orchards. So we had one devices in vineyards and orchards in all these countries. And we use, for example, weather stations for monitoring environmental conditions. Then we use the devices with sensors for monitoring soil conditions. Then we use the smart pheromone traps for monitoring some insect activities. Then we used our AgroNet platform, and I forgot to tell you that the same platform was used in a previous use case. We used our platform to collect all data, to visualize them, and to analyze them, and provide decision support to the farmers. And in this use case with the vineyards and orchards, we integrate our solution with Fede. Fede is a company from Spain, and they provide some automation in pesticide spraying. And we tested the solution in Montenegro. There is a huge vineyard with 2,400 hectares at one place. And they tested that solution, the one that we provided, and the Fede, and those integrated solutions, and they had some improvements, and actually they had cost decreasing in pesticide usage. And I forgot to tell you that devices that we used, the communication for measurements to the platform was LoRa or GSM, depending on what we had or what we created at that specific location. And then the project was finished this August, and actually today is the final review in Brussels, so I hope that everything will end. And after the project, what is happening after the huge project? Usually almost nothing, which is pity, because a lot of things are done during the project. So what we did is creating a digital farming hub. Like we use the core Demeter enablers and that stakeholder open collaboration space, and made a replica at digital to be used at digital agriculture, digital farming hub. Sorry, and so you can see on that site you can find all information related to Demeter, like all benefits, all stories about use cases, more details about each use case, and everything. And we created that enablers market with all enablers that were created and provided through Demeter, so all components. And that means that farmers, advisors, different companies can choose which component, which enabler they would like to use. And then there are contact information and all needed information for them, so that they can get in touch with those components providers, and then they can pick each component that they would like to have and create their own application that will help them to solve their specific problems. There is also stakeholders open collaboration space, where again farmers, providers, all different stakeholders can communicate. There is a knowledge base, there is that Demeter Enable Hub, there is a space for for discussing, for asking questions, to making a discussion about some topics. And then we created a chatbot. It's not like ChatGPT, but it would be something like that. So you can ask the question. Currently you can ask questions related to Demeter. But there will be more questions like related to agriculture that you can ask, and that you can actually different and answers will be provided. And there is a blog session where currently we have our partners from Serbia, from the Agriculture University, some crops, some problems in crop production, some pests, diseases, or even using insects as protein food, which is actually looks like a future that is going to happen. And of course, if some of you would like to say something, to write something, please send us, and we will put your stories here on the blog session. And then there are a number of information provided there, again, for the farmers, or other stakeholders, like events calendar, like open calls, grants, funding. Currently we have for Serbian region those open calls and everything, but there is a space to put also similar information related to other countries. Then there is a session related to different companies that are stakeholders in the food supply chain. So the overall idea is that each stakeholder in the food supply chain can find something at that digital farming hub and can find a company to collaborate with, and can find some answers, and can actually expand the solution that maybe they're building, or find a solution that will suit their needs. Okay, so thanks, that was all. I think that I didn't take all those 20 minutes. Okay.
Serena, it was perfect, so we have time. If you have any questions, any doubts that you want to pose to Serena, I think that they will be more than welcome.
Yeah, okay, yeah. If you have any questions,
I
will be happy to answer without switching on those slides.
Yeah, and I give you congratulations, because controlling a presentation that is flowing more than fast and us, is our task. For me, it will be. I don't know if there is someone that wants to pose some questions or some notes. If not, we will. Yeah, Jesus, perfect, amazing. I will put the mic on you. Thank you, Jesus.
Yes. Hello. So thank you very much for the presentation. It is very interesting also the way you are trying to give continuity to the results of the project. So normally this is a challenge for every project, and especially in this moment where all networks are flourishing and trying to collaborate. How is this catalog going to be exploited, or it's going to be maintained by the partners? Are now just static elements from the project that are on our website? Can you elaborate on this?
Just one microphone. For some reason, I forgot to just get it up.
You mean the catalog with those enablers? The catalog is there on the Digital Farming Hub, and there are details for each enabler or each component with the information and who is actually created that enabler or component, that you can get in touch with them, and currently through that SOX or stakeholder collaboration space, you can find there more information. You can download some documents and then use them. And I guess that in the future we will add more components, more enablers, and someone tell us that there is some fabulous component that can help farmers in this or that. And after the testing phase, or after having a feedback that the things is really working, we will add that on that catalog.
So, hello everyone, my name is Pedro Moura. This is my colleague Liette Rodrigues. He came from Inestec and will present some of the IoT technologies that have been developed under the TribeLab team and under the context of the Vineyards project.
As Senka mentioned, the main objective of the Vineyards project is to facilitate the digital transformation of agricultural production through all supply chains. But precisely in our pilot, the aim was to promote the use of IoT solutions and technologies based on monitoring and forecasting tools, supporting agricultural practices, ensuring that the crop demand and availability of the inputs are the ideal in each condition. With this, we ensure profit, sustainability levels, integrating the digital knowledge that we generate with the human expertise, developing an integrated decision support systems. From now on, we will talk about all the technology solutions that we developed. Starting with the smart trap. As you know, the crops are affected by pests and diseases, and given the wide range of attacking agents and the methods that they attack our crops, it's difficult to control them and to mount methods to control, given the manual requirements to announce and detect these crops, these pests. And this is not comparable with the attack patterns, since if we delay the detection, it can lead to chemical-based treatments with higher costs.
So, to automate the prediction process, smart traps have been considered rather than the conventional ones. However, the high costs for its acquisition do not promote to adopt the technology in large scale. So, our goal was to design a cost-effective smart trap that allows us to capture the insects and detect the presence of the new one. In that process, we can earlier detect pests and diseases and alert the farmer with that information. Consequently, the farmer can optimize the use of pesticide and reduce the treatment costs. If we can expand the installation of smart traps in multiple points of the neighborhood of the technology, we can promote to a prediction process shared between all the technology, and we can add value to the solution. Besides of that, we intend to have a smart trap that be interoperable with other systems and work as a gateway for other sensors. These sensors can be connected, wireless or not, to the smart trap and provide data to the farm. How we can do it? The smart trap was designed with a cost-effective hardware using low-cost components. Besides of that, we designed a structure that will be 3D print based. We also added a camera with high resolution to detect the insects and send the information to the farm. The photos taken was processed using machine learning algorithms to predict the presence of the new insects. We have been installed smart traps and other sensors to collect data in the field. Sensors of radiation, temperature, and humidity. To add value to the solution, we work with a smart trap with sex pheromone and delta configuration traps and chromotropic papers at the same time. So we can expand the technology to different species of insects and to different crops. Now we have some of the installations of the smart trap, and we have a dashboard that will be used to show you all the technologies providing data to our server. Here we have a little map with the pinpoints of the locations of the smart traps. And we have, in the other side, an image acquired from the smart trap. The image was processed using a machine learning algorithm and predict the presence of 2062 insects. As you can see, the red color represents the higher probability of an insect.
Regarding crop side, continuous monitoring of growth and development rates is essential to know how a crop responds to environmental and management conditions. However, the actual methods are not comparable with agronomic processes, since we lack non-destructive methods that work in the field, assess, evaluate different parameters, external and internal, during all growth cycle in different tissues.
So, we look for a solution to evaluate the crop production quality during the life cycle of the fruit. Parameters as water status and Brix degree have been evaluated, and we believe that the solution has also potential to be implemented after the harvest operation until the end user consumption. We designed the solution to fit three requirements, so the data should be collected in real time and in a non-destructive way. The solution should be portable and user-friendly, and should be adopted in large scale. To accomplish that requirements, we have the solution, a low-cost spectral sensor, and a set of FLEDs, infrared, white, and UV, to acquire the spectrum of light that is reflected or transmitted by the sample, for example, a fruit or a leaf. That spectrum can be used and can be processed to give us information about the physicochemical parameters of the plant tissue. These models run in the smartphone and can provide data in real time and in situ. Regarding the collection of the spectrum, we adopt a point of measurement method. So the sensor touches the fruit, for example, or the leaf, and collect the spectrum after the light is reflected by the sample. Besides of that, we considered USB-C connection in the technology because it will be a universal connection for the next year. So any user can have access to the technology through the smartphone. Now we have some images of the crop sign attached to the smartphone. My colleague Leandro has an example of that, and he will take a measure of the grape and the results. Sorry. And the results will be shown here. So, the light is reflected in the grape, and the spectrum is acquired. The spectrum is processed to give us the Brix level. After acquiring. Sorry, the data should appear here because it uses a wireless connection to MQTT, and the data is transferred to the dashboard. But something happens. You should see the Brix level and a reaction if the grape is good or not or sweet or not to heat. So it's the application of the crop sign and can be expanded to other parameters.
So, moving forward, if you want, we will try after the coffee break this demonstration, and you can also test it during the coffee break. Regarding photon cells, as you know, radiation is a key factor for agricultural production. So, since it's the basis of photosynthesis, for example, but for woody crops, usually row crops, the canopy structure strongly influences the radiation use efficiency. So by measuring this, the absorbed light, we can optimize this efficiency through some operations like pruning or trimming. But this operation is weakly adopted based on the currently methods and not defines the variabilities that we can have in a row or a field level.
So our solution tries to overcome the issue mentioned by the editor and adopt low spectral technology to acquire the spectrum of light that passes through the canopy. With some calculations, we can get the power radiation that reaches the ground after passing through the canopy. PhotonSense is also prepared to work integrated with other sensors. This is important to get at the same time spectral information from different locations. This is important to, for example, get information about the light above the canopy and below the canopy. And with that, we can make the difference of the radiation that passes through the canopy. Okay, to accomplish that requirements, we use multiple spectral sensors, equally distanced along the bar of the PhotonSense. All the sensors sense the radiation, and we can get the power radiation that passes through the canopy. The information is available through a mobile app. And the data is used to optimize the radiation use efficiency. PhotonSense works integrated with the technology crop sign. So the crop sign is located above the tree and the PhotonSense below the tree. Here we have application of the PhotonSense in Vineyard. And we bring to our presentation a small demonstration of the PhotonSense. It's a simulation. So what we try to do is to use the light to collect data to the PhotonSense. And we have a dark object that the anode will be moved to simulate the shadow to the PhotonSense, and we can see the spectrum of the light changing in the dashboard. So the object is located in the middle, and we have a decrease of the radiation in the middle of the sensors. So each bar represents each sensor of the PhotonSense. So, okay.
Now talking about the smart scissors and smart bucket system. In viticulture, estimating productivity is essential to optimize practices not only in the vineyard but also in the winery, ensuring the grapes and wine standard qualities. The actual methods are based on complex counting and weighting tasks. Even the autonomous ones are dependent on the canopy and can output good results at a regional scale. And hardly describe the three main components of productivity. There are the number of bunches per plant, the number of berries per bunch, and the weight of berries.
Okay. So it was essential to evaluate all the components with a complex system that integrates the cut counting and width measures. So the operation that happens in a single in-field and at plant scale with the plant resolution level. So to do that, we decided to sensorize the conventional tools that have been using in the harvest operation, so the scissor and the bucket. And with that, we collect the information of the cut counting and the width. This system can be also used along the other operations like pruning and thinning and include in the whole vegetative cycle. All the data is georeferenced with a location and is after used to create bigger maps and make it available to the farmer through a mobile app. Okay, to develop the solution, we work with conventional tools, and we had a smart component to them. All the tools connect to a mobile device, and send with the mobile device we can send the information through the cloud. In the cloud we have a decision support system that can be used by the farmer to support its operations. With the knowledge that we acquired from the system, we can combine the productivity estimation with the current and with metrics to optimize the agricultural performance. Now we have some of application of the system, and we have also a little demonstration of our colleague Ricardo walking in the vineyard and referencing the bunch weight in the map. And we have some graphs to represent the data. So it's just an example of how the system will work at that moment, and to create something like heat maps to represent the estimation of the product.
So now talking about pixel crop rollout. The performance of a crop is driven by its phenotype, and it's as a result of the interaction between its genetics, the environmental conditions, and the management practices. However, this is a time-dependent process, and if we try to manage and to know the behavior, the physiological responses by the management, we need to speed up this research workflow. So we need to bring the crop closer to the research center, integrate the technology to ease the phenotyping tests, and feed decision support systems with reliable agronomic data.
Okay. So our goal was to design a robotic solution to perform phenotyping and perform some agricultural operations. That operations happen in small cultures and near our research center. The phenotypic data is collected and will send to a decision support system to manage the interactions of the pixel with the culture, with the crop. After that, we can optimize the agricultural performance, and pixel crop robots can be adapted to work with different crops and have a portable application, so we can move the pixel into different locations. To develop the pixel with the phenotype capability, we equipped the pixel with optical sensors that can be used to monitor the plant growth in a non-destructive way. Also, we had a manipulator to the robot. The manipulator has an end tool, and the tool can be changed between the agricultural operations. Pixel uses also ultra-wideband and LiDAR technology to ensure centimetric precise location, and its size can be adjusted and use it to move the pixel into different locations that will be important to allow us to study different genotype behaviors in different environments. Here we have the pixel crop robot and the hand. Sorry. And we have the tool for watering. The pixel crop robot was installed in a greenhouse near our research center, and the greenhouse was installed in the context of the project Emitter. Now we have a little demonstration of the pixel working to perform for watering in working. Sorry, the robot is moving to a plant to perform watering, and the plant, as we can see here, is in water stress, represented by the red color. And when the pixel water the plant now, there is an increase of the width measured with a limiter called custom made. And that width represents that the pixel water the plant and should not be in water stress.
Also, we designed a different case study in the Vineyard where we can merge our technology ecosystem with the crop growth cycle. For instance, the next month we'll open the pruning operation, and this operation we can use the smart scissor and smart bucket to weight the cans cut and mapping the plant vigor. The remaining examples will be shown during the coffee break in a video, so if you have any doubts about it, feel free to contact to ask us. Thank you for your attention.
Okay, so here we are. Let's resume the event. I hope you're having a great day. So my name is Jesus. I am the regional cluster leader of the Iberia region in the Agrofood network, but my full-time job is technology transfer manager at Eureka, which actually is not showing properly, right? With the PDF. So I'll do the change in a second. Let's see if it shows better. And meanwhile, since this is going, or I expect this to be an interactive session, at least I have 3 questions for you. I would like you to take your phone, your smartphone, and go to slide.do. Probably you've done this before. SLE.do. So here you have the things. Yeah, good. So go to this website. It's in browser, and you have to enter this code: 25, 26, 27. Easy. 3 numbers: 25, 26, 27. Okay, I'm gonna move from. Okay, so I have 3 questions for you. Now we will do the first one, because I like to know who they are, and probably you would like to know as well who is sitting behind you. So there is a first question here that you should be able to see. So please, if you start to answer, you can see here how the bars are moving. So, yeah, 25, 26, 27. 25, 26, 27. So I'm asking you who you are, right? Are you a farmer or somehow related to production of fruit, vegetable, to the agri-food production? Are you an agronomist or agricultural service company provider, technician, like a technology service company provider, a research institution, university, RTO, an investor? We have any? We have investors. This is anonymous, so you will have to find them. This is like a game. So it's up to you to show up at some point. Do we have politicians as well? I think we can see it. Okay, let's see. No. Or maybe they're a bit shy. Okay, so I'll leave this open so you will see it in your phone, so you can still answer if you have not. And then let's move on to the presentation because the time is limited. So, if you are somehow here in an event related to robotics, IoT, digitization of agriculture, you are somehow already convinced that they have a value, right? And you can pose it in many ways and use many arguments, but there are certain macro trends that makes really the robotics and IoT a valuable tool for the agriculture. So the climate change, global warming, also the demographic change, the population moving from rural to urban areas, which has been there for years. So in some way or another, you, or especially the farmers, are experiencing this into their day-to-day activities. So robotics, IoT, digitization in general, is contributing to bring back the control in the hands of the farmer. So it's providing tools so that the farmer is more able to perform a crop management as it used to be, because all those trends are introducing uncertainty into the crop management activities. There are also other macro trends, at least I like to point out this fact, in the sense that, so these are data from the CIMA, so the European Agricultural Machinery Association. This chart is the registration of tractors along the years, quarter by quarter. You can find those data on their website. This is not the accumulation, so this is by quarter, the number of registrations. If we accumulate them, we could see the trend that probably we all know that is that tractors are more and more used in the agricultural sector. But what is more maybe representative or relevant, or even shocking maybe, is how the power of these tractors split across the different power ranges. So maybe I'm not an agronomist, I'm an engineer, so I can miss this interpretation, but maybe here the high-power tractors are more for extensive crops and this type of agricultural activities where you have to work big surfaces, plants, and so on. But you can see certain maybe concentration of medium to low power tractors, I would say, which means that there is space for lower energy consumption machines, let's say. And at the end, when we are talking of robots, we are talking on this side of the line, right? And I like to see this way of the tractor moving towards some autonomous vehicle or connected device like this. This is not my slides, I'm always using and trying to recognize the author or the reference. But the tractor used to be an isolated machine, then it turned to be some more sophisticated device, connected to a certain point, and then we are more or less, hope you agree, but more or less we are today here. So the tractor is connected, and it's even reporting data to some central server or farm management system. But even more, we are moving into an ecosystem where the tractor, the vehicle, will be just a system of systems. We've seen sensors, AI, data-driven applications, we make extensive use of AI, and everything will be, an ecosystem of systems. And because basically the ecosystem, if we focus on the robotics part, so I like to identify three main layers of a robotic system. So we have the high-power ones, not all of them, you may recognize some. Sorry if you are a company producing robots and you're not here, this is a completely random selection from myself, and it's very quickly outdated. So the high-power machines, kind of medium, normally energy-powered, or green energy-powered machines, let's say, robots, and then we have drones, which actually could be the most mature robotic device that is currently used in the agricultural sector. But other than the technical challenges that all of them are facing, which are normally tackled in these kind of projects like Scorpion, Pantera, Demeter, and others, we have other challenges related to the economics, to the scaling up, to the logistics, to establishing the price, the business model. So as a farmer, do I have to buy the robot? Do I have to pay for the service? So we need actors in the middle, stakeholders that complete the value chain. So what about the robustness of the solution? So today training, what should the robot do? Go out or not? So if you ask the farmer, maybe just go out and work, but if you ask the technician, better not. So it depends who you ask. Interoperability in this ecosystem, maintenance, so we need plenty of things yet to be solved. And the research projects, normally, just to focus on the technical part, maybe business model, but what about the rest? So we need much more here. But things are happening, this is, again, a random selection from myself of headlines happening in the last 2 years, of facts that are evidences that proves that there is money, there is private money, especially private money coming into the sector. Normally from big corporates or VCs or family offices, putting money, which is good. But maybe it seems it's the only option for a small startup starting into the arena to end up being bought by a corporate, which, I don't know. I mean, I think we still need to investigate all those options for companies to really scale up. But things are happening, and the money is around the applications. And this is why in 2019, and because of all of this, so this is a European project, so we made a proposals made by Vineyards and by a consortium of 37 partners, formed by research institutions, companies, clusters, industrial associations, to boost and foster the introduction and the uptake of all of these technologies. Right? So this is a project ending in February, but this is turning into an innovation network recognized by the European Commission that will work under the umbrella of the European Robotics Association. It will be an independent entity, so a RoboFood project will turn into a RoboFood network as an independent entity, and it has already signed a memorandum of understanding with EU Robotics Association, which is the European Robotics Association, gathering all the robotics industry and also end users. So we have, in order to be present and close to the companies, we have organized ourselves in clusters, similar to what the Meta did, similar to what all these kind of big projects try to do. In order to, let me show which is the effect we're trying to create. So if I focus on the Iberian Peninsula, which is the regional leading in a global, so the starting point is set off a list of digital innovation hubs, competence centers, laboratories which some activity in the agricultural sector. With a set of technical capabilities which are not necessarily connected. So RoboFood is willing to build a service catalog, a structured service catalog, organizing all the technical capabilities of all these digital innovation hubs in a structured way. This should be transparent to the companies and to the farmers and to the politicians and investors. So this is our challenge as a network, to be connected in some way. And why this makes sense? Because this is just the example of Eureka. This is how we are present in our region, Catalonia, the northeast of Spain. So we have laboratory and headquarters close to the different regions and close to our clients, close to the companies. And this is, I know this is the same case for Nest, Fraunhofer, from Wageningen, and from others. So they have capillarity and they are close to their customers and companies. So we want to have this network of digital innovation hubs so that a company here in Catalonia or here in Porto can, through a single window, can access the whole network. At the end of the project, we have gathered some amazing numbers, I think. So we have gathered 92 digital innovation hubs and competence centers. So we started with 30, not all the 37 were this kind of digital innovation hubs, but so we started maybe like 20, something like that. So now we are 92. All along the project, we have invited others to join the network. We have funded 27 experiments, where more than 100 companies have benefited from that, and I will go a bit deeper on that. And we have organized 3 pitch Eurobot events, which I think is something different from other projects, and we have the idea of keeping doing this. So more than 40 projects had the opportunity to present their ideas in different status, let's say, to investors. And from that, we have not tracked, the evolution of possible deals, but this is an idea of an indicator that we should track in the future. And we want to keep doing this kind of events. So if we put a focus on the experiments we have granted, we have done money, we have released some money, They were used not only to test technology, so the project was structured into the three phases: market, development, and design, market, and development across 18 months. So at the end of the project, I mean, they are different, so the starting point was different, the end point is different. Some are ready to be launched, some still need further research and investment. But that was very useful for our network in order to test the services, in order to see and discover the needs these kind of companies and small consortium of SMEs would need from our network. So it's kind of a discovery exercise where regional cluster leaders and other institutions, for instance in Iberia, so it's been led by me from Eureka, but Ines Tech and Tecnova in Almeria are also part, and now more digital innovations are part of this. But it was useful to test all these kind of mentorship services, technical and non-technical. During the project, we also performed some market studies. We contributed to the strategic research agenda document that was elaborated through Robotics, but also through the new association ADRA, which is gathering the AI data and robotics ecosystems into a new association. So all these activities were performed in order to provide new information and insights to the whole community. And at the end, now that we are turning into an innovation network, separated association that plan to be sustainable starting next year, January next year. So we basically categorize our services in 4 blocks. So we are providing the skills and training services, ecosystem and networking, testing for invest, and support to find investment. So skills and training, I think it's clear, training for SMEs in order for them to access to the whole know-how and technical knowledge in the network, but also to farmers to be reskilled or upskilled with new digital technology. Ecosystem and networking, you can easily understand what it's about, but it's also about building this value chain that we need for the robots to be really in the market. Testing for invest, it's very important for technical companies that want to produce cheaper and quicker the technology, and then supporting to find investment, like the pitch you robot event. And here, I'm waking you up and almost finishing for my 2 second questions. So if you go to the application now, you could see a second question about the services. So I'm asking you, just give me a sec. So I'm asking you about these services. Which of them do you think are the most important? So give me a second, it's loading the application. So you have them in the application. I'm asking you to rank the services according to what you think is the most important or who would have the highest impact into the ecosystem in order to introduce the robotics and IoT technologies. So you can rank all of them from 1, the most important, to 4, or just maybe 1 or 3. So. Okay, and I'm going to show you the results where you're answering. Okay, here you can see how this is evolving. Okay, so I think it's easy to make it work, right? You have this, you can basically drag and drop, or you can directly click 1. So this is my second, So this is how this is evolving. Okay. So this is important for us to understand, where to put the effort. So imagine that this is now a project that ends. There are certain founding members that will commit to putting some effort, probably some budget as well, and then we need to be smart on where to put those efforts to really try to make something sustainable, right? Okay. We have 33 answers. I know we are almost 50 or more, so I'll give you a bit more of a time, but we are quickly moving to the next question. So I'm asking you a bit of a controversial question, or quite a direct question, but I will change in a minute, also related to the services, the four main, these four services. So, tick those services that you would be willing to pay for. Okay, that's more tricky. I'm not telling you anything about the services, I'm not telling you whether this would be 100 euros for the course or 20,000 euros to access an infrastructure and test something. So I know it's a tricky question, but I don't know. Try just as a simple exercise, try to imagine whether you would where it comes from, but it's an interesting observation that way. Okay, so this is now ready. So please let me know. I'm not going to charge you anything at the end of the event. I'm not going to go to you to sell any of the services. We're still in the process of defining those services. So please let us know as a network, which type of services would you be willing to pay for? Starting from this feedback and previous feedback, of course, we have other channels to ask you for more precise questions about this kind of services. Okay. So interesting how this is moving. So I think knowledge is always very welcome for everyone. So knowing more, knowing how to use things. I presume there are technical companies, research institutions that would pay for test different services. And then the working ecosystem, still it's maybe more difficult to see the value and fundraising, since you have your own channels to get the money. Okay, I'm going to leave that one open. I cannot leave the two, but I will leave that one for a while, even after my presentation. And I think it's time for me to finish. Okay. So the project, as a European funded project, ends in February. We have already signed, actually, Wageningen have already signed a memorandum of understanding with Robotics. We are constituting a new association in this last quarter of this year, and then we expect to start running operations in January. We have some ideas on how, but hopefully you will let us know. We will let you know how it will be. We are very much interested in establishing alliances and connections with other similar projects that you may know, like Vineyards. This is why I was asking, like, for these kind of assets from the projects where they will be, how important for the partners are to give continuity to this, how a global food network can incorporate this, or can open just a door for the companies to access the website or whatever. So this is it from my side. So thank you very much. I ask you to keep updated to the next meeting.
Yes, welcome, good morning. So I will talk to you about experiences from implementing autonomy in agri farming systems. So I hope to explain a bit from the projects that we run from Wageningen about some small and large-scale pilot tests we do in Europe. First, I explain a bit who I am. So this is what I like most. I studied agricultural engineering in Wageningen. So the pictures on the left is from my PhD. That's from the old days when we didn't have any AI to detect weeds. So we still had to think on our own what kind of algorithms to develop. And that brings me to a first question to the audience. Who of you has been using ChatGPT in the past month? Please raise your hands. It's almost about half. So it means that almost half of you thinks that AI is a good tool to use in your day-to-day work in research practice. Keep that in mind, because we still need to think ourselves as well, how we develop AI and how we put it into practice in our projects. The slide here is I want to explain to you is what we do in research in controlled environments, but also in the open field environment. So on the one hand, we want to develop robotics from simple to complex operations, That's much easier in controlled environments if you compare them with the open field environment. And in open field, in arable farming, we have to deal more with the seasonal challenges. And there's only a small period of time where we can run the actual experiments and do the test, because if we consider harvesting or weeding, it's only a small part of the season where we can do our developments. And that's often what we also need to discuss with our investors, and also in adaptation to farmers. That's an extra challenge for us. The paradigm that we're trying to do our research on in Wageningen in these projects is that we go, as I've shown here in the slides, that we go from learning to improving to sharing to applying knowledge. So we want to develop robotics in a way that we can learn from humans how we behave and how we do our things in the agricultural system, in terms of how we grow crops and how we handle crops during weeding and during harvesting, that we can learn from what humans are doing, how we can transform that into our robotic systems. I will show a few examples of the robotic solutions that we developed in EU projects, and I will try to explain what the challenges were and what we've learned from it. So the example you see here is from the sweet pepper harvesting project. The project is finished now already 5 years ago. The biggest challenge was to find and detect the sweet peppers properly and find a location where to actually cut the sweet pepper from the plant. And I think this was one of the first projects where we used AI to detect which sweet peppers to harvest. And even the most interesting part was that we used a fully digital twin, like a model plant, a 3D model plant, even using artificial light and rendering and shading to train the AI algorithm which sweet peppers to harvest. So that we could already go into the greenhouse with a fully trained AI model, that we only had to slightly adjust to have the robot harvest the right sweet peppers. These days we are also working on projects on robotic harvesting and pruning in orchards. And you know, from the robotic apple harvesting, it's a lot of repetitive work in there. The logistics of the harvested product, they have more or less already been solved by commercial companies. And so it's as soon as the apples are picked and they go into the crates, that's already mechanized here. You can see that we just placed a robot on a position where normally a human would be standing to pick the apples. And we are now in this project looking how we can combine humans picking apples with robots picking apples, so that we can gradually replace human labor by robotic harvesting of apples. Even more challenging is this research on a pruning robot, because for pruning you need much more intelligence also on which branches to cut and which not to cut. And so it's not so easy to detect where actually the scissors should go to cut the branches. But it's the most difficult part is also how can we learn from what humans are doing in an orchard to determine the intelligence behind which branches to cut. And that's quite difficult, and that's also the reason why we work together with the people who actually plant the trees and who are responsible for normally for the pruning, because you could probably also think of just changing the way you grow the apple orchard or the pear orchard by having fruit balls or different ways how you grow your plants in the orchard. Well, if we move into the mobile field robots, we work a lot in research projects on the automated implements and on the autonomous platforms. But we see these days that the autonomous platforms, they are there. And so there's many suppliers now of autonomous technology simply to drive in an orchard or on an arable field. You just send the route and the robot will follow the route based on GPS. So the biggest challenge is not anymore to just drive in a field, but the biggest challenge is to think how can we run the task that the implement is doing without any human intervention. And so we see here in the field demonstration where we have two robots. One is the Nio and the other one is the Robotics. Both are being demonstrated here by the Dutch importer of the two robots in a in a test field. But already during this demo, we could also show that there's some challenges if you have multiple robots or even a robot and a tractor working on the same field, because these systems, they do not communicate with each other. And so if they get very close to each other, both systems stop because they think there's an obstacle, whereas they could just have passed next to each other, was not possible yet. So we see that we need much more adaptations on the systems, and they are now very single task oriented. So it's either a weeding robot, or it's a task of seeding, or it's a task of harvesting. Robots cannot work doing multiple tasks. If you look into the larger robotic vehicles, we see a trend now towards developing retrofit tractors and also autonomous robot platforms. And I think we need both to make the transition and help farmers to develop autonomy in their fields. And so the retrofit tractors, we need them because we still have a lot of challenges with bringing robots to our fields on public roads. And I do not see it happen that we have autonomous robots going on the road. So, and for that purpose, the retrofit tractor is a good choice. And also especially if you look at the large-scale field operations that we do in Australia, in Brazil, and also in Eastern Europe, where we have large fields of wheat and soybean and corn, where we also need autonomy. There you simply need high-power machines that you also want to run with a human operator. On the other hand, the autonomous robot platforms without a cab, there's also a market for it, and also combinations of the two. I have a small few examples here to explain a bit, and there's quite some companies now focusing on retrofit kits on tractors. But the challenge is how do you switch from human to autonomous operation and back. So if you put autonomous modes on tractors, how do you also make sure that you run the tractor still safe if you go on a public road? And there's quite some challenges to convince regulatory boards and also insurance companies that the tractor is still safe if you use it on a public road where there's also electronics on there to run it without a driver. So we need to invest in explaining to the people who do the homologation that we provide them with safe technology. There's also quite some companies now looking into the ISO standard, the TIM standard. It's called Tractor Implement Management, TIM, Tractor Implement Management. And that's the way how we can control tractors from implements. So an implement, for example, a baling machine or a harvesting machine, can tell the tractor to slow down because the capacity of the machine is not high enough. Or it can even tell the tractor to speed up because the implement is not running at optimal capacity. So, and in this tractor implement management, there's also the safety and security is in there, so that only certified machines, also with the certification keys and security keys between the implement and the tractor, make sure that systems cannot be hacked from outside, because that's a severe risk for all these machines. And tractor implement combinations is that if you get any hacker from outside on your machine, you don't want the tractors to go crazy and being a safety risk. And you all know that last year when Russia invaded Ukraine, that even John Deere was able to turn off machines that were located over there. But if John Deere can do it themselves, it also means that other people who potentially have access to machines to do things we do not want to happen with machines. This tractor implement management based autonomy is now taking off, so there's now more and more companies offering these solutions. I've shown here the Savanto system from US. They've shown it on the Kubota tractors, but also on the Fendt 700 series. You can now commercially already order a retrofit kit system fully based on ISO to run your tractor safely through a field. You might have heard that even GCA Technologies, also a company from US, is now part of ECHO. They offer also retrofit kits, and I expect that now in the coming years we will quickly see more and more solutions being offered by the larger machine manufacturers to show that they can have multiple tractors operated by just one tractor driver, so that you see kind of master-slave systems and even systems where you have tractors feeding or unloading during harvest. One of the examples that has been recently launched is also a combination by Dutch company ncia. You might know that ncia robot is being developed by 3 former colleagues of an eco branch from the Netherlands. ncia is 50% owned by Klaas, and they now have the combination of 3A, they call it Advanced Automation and Autonomy, where they combine isolous machinery with a robot, with a tractor. So they can run also based on TIN, the Klaas Xerion, but they also integrate the machine information in this triple system. So they share the information of the cultivation machine behind the robot with the cultivation machine behind the tractor, so that they can optimize the speeds and the working depth of the machines, and even that they can use that digital information to even see better in the next operation in the field. So this ecosystem is now taking off. I expect to see these first unsupervised systems to be expected in the farms soon, even from Lady, the one that's on the left top. You might know Lady from the milking robots in dairy farms. Lady is now offering this Exos robot to harvest fresh grass and to bring it multiple times a day, fresh grass from the fields to the cows in the farms. They are now commercially selling this robot next year in the Netherlands, and I expect that it will be ramping up quickly over Europe and worldwide. Let's explain a little bit further about the European project Hops for Crops that we are involved in. From Wageningen we are coordinating with a lot of researchers throughout Europe. The project where we work on adaptation of robotics into agriculture, and we do that based on development of autonomous vehicles, smart implements and the farming controller. Because what we identified when we started the project is that it's not only about bringing technology to practice, but we also have a lot of non-technical challenges. For example, about citizens, about policy makers, about financing and insurancing. How do we bring that together so that robots and autonomy are truly accepted and adapted by farmers? So that's why we started 4 large-scale pilots, one in Vineyards in Greece, in apple orchards in Spain, pumpkins and sugar beets in the Netherlands, and in France also in Vineyards. And one of the important parts is about the farming controller, because we know that it's difficult to implement robots and autonomy in your farming system if you don't know how the robot will behave. And normally you communicate with your tractor operators, with your drivers, with your workers. You tell them that they need to spray a piece of the orchard today, and they will simply do it. But you cannot just talk to a robot and say, hey, go spray that part of my orchard. And so we need to know in advance how that will work. So we decided to develop a digital farming controller so that you can orchestrate the farming system, so that you can work together with multiple robots, or even with a human-driven tractor and a sprayer and a robot-driven sprayer, that you decide on beforehand which pieces will be operated by the robot A and which by robot B, so that you get an optimal plan where the robots will go and how they will refill their tanks based on energy use and the tasks that they need to do, so that you can optimize that system. And that digital farming controller, we use it to also schedule the tasks in these 4 pilots. That's what we will do in 2024, in the coming season. So we will use the routing from the farming controller to do mechanical weeding in vineyards, mechanical weeding in arable farming in the Netherlands, to do orchard spraying in Spain, and to do table grape spraying in Greece. And And you see here in the pictures directly what kind of robots we use. So it's different brands of robots. So we use the Robotics in the Netherlands. We use the sail robot from agriculture in France. We use a retrofit kit tractor in Greece and in Spain. But if we want to make this a success, the farmers also need to trust the technology of the implement. And so we need much better understanding of the implements, of the tasks that the robots are doing, and we need to make them truly unsupervised. And so we need much better feedback monitoring on machines. For example, normally in a weeder, we only use a camera to detect the weeds, but we almost never use cameras at the back of the machine to see if we correctly remove the weeds or if we were damaging the plants. The same is true for spraying. Normally we only spray the product, but we never check afterwards if the crop protection chemicals were hitting the right leaves and the right parts of the plants. We simply trust that there was that all was going out of the nozzles and hit the right spots. So that's what we do in the Robotics project here. What we did is we put cameras in front of the robot, but also here at the back of the robot, to see if we were not damaging the plants after we were weeding. So we are simply counting the plants and checking if the implement position is just on top of where the weeder should be, so that we were not cutting the roots of the plants, that we were not hoeing them away when we were doing the weeding operation. And this is something that can give the farmer trust and give them information on how the weeding was done. We also provide them live access to the camera stream, so that they can simply see from home if the machine is still working fine. Because that's the biggest risk for a farmer, is if you go into crop protection and you send a robot in your growing crop, how can you trust the machine? You need to know what's going on in there. But for those smart implements to work and have all the feedback systems work properly, we need good connectivity. That's why we did this project a few years ago. It was together with a mobile phone operator in the Netherlands, with KPN. We tested their 5G connectivity to see if it was possible to send all the images real time to one of the cloud servers 200 kilometers away from the field and receive the signals back. We even succeeded in having a real-time spot sprayer running just a YOLO algorithm 5 years ago. The raw data was sent into the cloud and the result was sent back within 20 milliseconds, soon enough to have the data on the machine and run it at a high frequency. We're also working on in a different EU project. Now I'm going to some other examples. It was a project also funded from the same program as the Scorpion project. We ended the Galileo project also in September. And here we show how we can detect the Rumex weed in grassland fields and run the robot autonomously to laser weed and electrocute the weeds in there. And here the same was true if we had the discussions and the demonstrations with the farmers. They asked us, how do you know for sure that it's not cutting the wrong weeds, and how do I know that the grass is still growing fine the next time the robot is going into the field. And so they want feedback on the operation that we are doing in the field. Some other example is what we do is evaluation of how robots are performing in the field. So we work together with a startup from the Netherlands, Robot. I think they also participated in the AgroFood network multiple times. So we did evaluation tests simply by counting how much weed was removed by the Delta robot arm to help them provide objective data to farmers and to investors to prove that this technology is worthwhile continuing to develop. So you all know there's a lot more weeding robots ongoing and being developed. I expect that almost half of them will fail because they do not invest in the right key technology. And what I just explained, a lot of them, they are also focusing on autonomous navigation, whereas I think it's much more important to focus on the core technology of having an unsupervised implement. And you need to know for sure that you do the weeding right. And if you do the weeding right, you can sell your weeding tool to whatever autonomous implement builder. You can even sell it as an implement behind a tractor, and you can have different gradients of implements and autonomy in there. I'm almost at the end of my presentation. There's one more thing in this adaptation part that I just want to explain, is that we also help farmers and students with some of the partners of the Robots for Crops project in also making available digital twins and simulations. Just want to mention here that even from the University of Hohenheim, there's a package from another EU project to bring precision agriculture via gamification. So I know I have 3 boys at home and they play farming simulator. So that's fun to tell them you can even try and learn already precision farming, and I hope that probably I can challenge you to bring one of our autonomous robots also in such kind of a game to make agriculture interesting again for our future students. Just think about it if that would be possible. I think many of us, we have the 3D models available, but we just need to make these kind of gaming companies also interested to bring some of our modules in there to make robotics fun for our future generation as well. So with that, I just want to end my presentation. I would say go for agro and tech, and make sure that we have enough food for the future. Thanks.
Before starting my presentation, I need to present what is in ncia. And because we present a lot of technologies, and at the end, we don't have technology to offer you after today or after tomorrow. So we produce technology for other companies to put in the market, okay? So before me presenting what is in ncia perspective, I will put a video, because it's a very fast video. Sorry. Sound is not playing.
The future isn't built on mimicking. By following rules or taking the safe path. Success doesn't come with repeating strategies or conforming to old beliefs. And we at ncia should know it. Here, we don't take no for an answer. Our mission is to foster pervasive intelligence, enabling science-based innovation through the transfer of knowledge and technology. ncia doesn't turn away from today's biggest challenges. In fact, we welcome challenges. Cancer and neurological diseases screening and diagnosis, sustainable production, food security and safety, decarbonisation of the society, large-scale integration of renewable power sources, flexible, autonomous, collaborative production, digital transformation, environmental monitoring, sustainable sea economy. We work for social fairness and prosperity, for the empowerment of people with a new generation of technologies, while mobilising industry for a clean and circular economy. We do this by developing technology watch and competitive intelligence, identifying market needs and relevant internal competence combinations. We are a hub of talent, founded and inspired by those who wanted to build a bridge between knowledge and business, bringing together academia, companies, public administration and society. More than 200 people transferred to the work market per year. More than 1,000 collaborators from 35 nationalities. Home to laboratories, business incubators, startups, amassing patents while affecting public policy, equipped with values, creativity, boldness, and motivation. With more than 250 ongoing projects per year, it's the biggest institution in its area. Always with the people's and the planet's best interests in mind. Our collaborators set off the beaten path, on the prowl for innovation and always looking towards the future. From knowledge generation to science-based innovation.
So, this is InESTech. So we try to help and support society to innovate. And now we do it in our agri-food system this. So we have two vehicles to do that. We have the Tech for Agri-Food, that is an initiative that scouts needs on the sector and try to find, with our knowledge, new ways to solve that problem, and we can go to the companies to help driving a new product for the market. Another vehicle that we have is a Tribe Lab, where we develop robots and IoT for agriculture. This is a unique laboratory that we might say that it exists in Portugal that is focused just in agriculture. And what we do with that? We have done that looking for the why we need technology in this sector. So we look at for the Portuguese reality that is mirrored around along Europe, that is small farmers that need new technology to support the new environment impacts, and then need technologies to support them when there is no human labor. So we are looking for this Portuguese reality and needs, the cost-effective need solutions that they need also. We are looking for the strategic agenda for European, for robotics and IoT, and we are looking for the main trends in the big players in the sector. That is, the big manufacturers of tractors are also producing small machinery, and they have also a problem. Yeah, a big machine can do a lot of work, but if it fails, the downtime, it might be big downtime and a huge cost for the farmer. If you can split this in small machines that can work autonomously in the farm and do this operation, if one fails, you can have another one replacing the other machine. Besides, we have less soil compactation, and we need to be aware of that. We have problems with the soil compactation. So this is where we will believe why we should develop robots and IoT. And so this is our mission, that is to develop modular and safe autonomous size agricultural machinery less than 1 ton that can operate in 6 units in greenhouses and in the biome in forestry. Besides of that, we are looking for IoT that are cost-effective and can be accessed by any farmer. Doing that, for driving our research, we have put these milestones to ourselves. That in the first goal was to have a first generation of robots navigating fully autonomous on these kinds of vineyards that you see in the windows without falling and without losing the localization of the robot. Besides of that, we are moving now to the second step, that is having robots that can apply the right product in the right time, in the right moment, in the right place on these vineyards without the losses. Besides, we are moving now also for pruning and harvesting robots that can overcome the problems of human labor scarcity. Being said that, we are more than 30 people on this laboratory, not just electrotechnical guys, not just mechanicals, but we have also people from agronomy to give a huge perspective when we are developing this technology. This is how we organize the knowledge that we have in the laboratory in terms of experience and in terms of robotics and IoT. To drive this, of course, we need money to drive this purpose. And to do it so, some of these projects, they already have been explained to you what they are doing, what aims to do. But in Portugal, I want to recall, because Dimitar and AgroFood, they already explained what they do and what they are, their purpose. I want to speak about the Scorpion, that is a European project funded by USPA Foundation for a Space Agency, and where we are developing a robot for precision spraying in slope vineyards with 10 more partners. Okay? Being said that, just want to call this attention to you. Please never use just GPS. Please call it GNSS, because otherwise you will not have the robots operating fully autonomous with only GPS. Okay? This kind of videos. We tried, it's not possible. So, this being said that, and I will talk a bit more about the Scorpion, I want to talk about the project Vineyards, that is a resilience project that started in Portugal. with 18 million of euros focused on innovation of the wine sector in Portugal. It's a huge project. I think that we should be proud about that. I will speak about what is the first results of this project in the after slides. We have also a method that tries to reduce the use of chemical products on the mowing process in vineyards, and we are doing that with our robots. Being said that, on the Scorpion, I want to give special attention to this project. On this project, we have developed 2 robots, and this was done with the support of 10 partners of this project. You can find more information on plants that exist in that places. Besides of that, after that, or in the meantime, we figured out that to transfer this to the market, we need to design or make prototypes more closer to a more closer product. And what we mean with this, we mean that we will use technology full design from scratch. And we do this considering 2 perspectives. The robot should be below 1 ton, should be able to operate in any kind of steep slope areas like we have in the Douro region, where the terrain is not flat. And should we have 2 kinds of ways of designing this robot. One that is more design building, that can be integrated via a company. Another one that is more cost effective for the farmer. That we don't care about the design, but we care the price and the functionality of the robot itself. And for that reason, we have these 2 robots that they were fully designed from scratch. The better robot was fully designed from scratch on the Scorpion project, and the Molly was partially designed on the project, and the Vine and Wine project and the Priest project. Let me say that, sorry. Robotic.
So you can do that for
What? Yeah, of course, that was. So, this robot is kind of flavor. So you can have a tool for mowing, you can have a tool for spraying, or you can use it simply for logistic purposes. And so, you will have this demonstration of these robots in the afternoon. At the moment, this robot can do mowing, spraying, soil fertilization, and logistic operations. So it's a multifunctional robot that the farmer can buy for this kind of operations. This is the second one without the spray. I will also show you with the functionality of the spray. That is a besides that, with the spray. Okay, here we go. This is, both of them can trespass rock or something that is higher than 20 centimeters and stay with the 4 wheels traction on the soil. This ensures the stability of the platform and also ensures the traction and the motion of the robot itself. As I mentioned before, I don't want to enter too much in details because in the afternoon session it will be shiny and you will see our robots, hopefully. As in Hashtag, we produce prototypes. At this moment, this kind of robots, they are in the TRL 6 and 7, so you don't should expect products ready for the market. There is 3 levels of TRL that we need to overcome, but at the moment we have problems, or we need to optimize the IP protection and optimize the production costs and the safety certification for this kind of robots. But just entering in the most important part, this is the first robot, the molder with the fertilizer and the mowing tool operating in this steep slope vineyard. This is a photograph for yesterday. This is and this is another robot that you will see in the afternoon that is the same robot with a sprayer for precision spraying in steep slope vineyards with a different configuration of beta. And now you have beta. That beta goes far away in terms of precision, of spraying. This kind of robot can reduce to 0 loss of spray in vineyards. Besides of that, it can transport UV lights to avoid chemical products in some specific applications. And is a beautiful design, no? I like it. So, is a robot that is most ready to go to the market? It's our belief. We have some efforts, just to complement what Jesus has mentioned before, because there is always that valley between TRL7 and going to this market. So this is a robot that is able to move on this kind of vineyards and be precise and recover any loss that we can have on spraying treatments. Besides of that, it's fully electrical and is 20 times more efficient than sometimes of the normal tractor.